We're getting into Unit 8 for third quarter. And Unit 8 is about ratios, rates, and proportions. Rates are comparisons between two quantities that have different units of measurement. For example, if you're driving in a car and you're saying I'm going 50 miles per hour, then I'm comparing distance to time, miles to hours. So those are two different units, and that would be a rate. Another example would be money to pounds. So for example, if you go in the grocery store and you want to buy bananas and it says that bananas are 59 cents per pound, you're comparing a dollar amount to weight. So you're comparing two different units of measurements, and that will be rates. Ratios are nothing more than fractions. Ratios are a comparison of two quantities using division. So for example, when you are writing ratios, you can write that three different ways. You can write a ratio as a fraction like you see here, men over women, and we don't say over in 6th grade, we say divided by. So this will be men divided by women. You can write it with the word to here, men to women, or you can write it with the colon, men colon women. When you're writing ratios though, whichever word is said first is the quantity that you write first. So in this example, if I were to say there are 36 men for every 8 women, then the number 36 will need to be here as the numerator in this ratio, or first before the word to in this ratio, or the number 36 will need to be in front of the colon as written in this ratio because the word men is first. When you are trying to compare ratios, that is proportions, or creating proportions, and proportions are nothing but equivalent fractions. So two fractions that are equal to each other, where A over B is equal to C over D. So in this example, my A is 3, my B is 4, and that's equal to my C of 9, and I don't know what my D is, so I would use a proportion to figure that out. So for example, in this example, if I wanted to figure that out, and we've done this before, and you've done this before in elementary school as well, I would just say, how did 3 become a 9? Well, 3 became a 9 because I did 3 times 3. So I would do times 3 here. Remember the rule. Whatever I do to my numerator, I have to do to my denominator. So since my numerator was tripled to get a 9, I have to triple my denominator in order to keep these fractions equivalent. So this question mark will become a 12. So basically 3/4 is equal to 9/12. And I can reduce 9/12 down to 3/4, so that would be true. And that's all proportions are equivalent fractions. Another example of ratios would be this. What is the ratio of blue circles to black squares? Well, if I wanted to figure that out, remember my blue circles are first, so that's what I will count first. I will write that quantity first. There are 1, 2, 3, 4, 5, 6 blue circles. So I would write the number 6 first. And then there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 black squares. So I can write that 3 different ways as a fraction, 6 over 12, using the word to, 6 to 12, or using the colon, 6 dot dot 12. Either way I write this, the quantity that represents the blue circles need to be first. And since there were 6 blue circles, I have 6 as my numerator, 6 in front of the word to, and 6 in front of the colon, so that that quantity is represented first. Also, you want to make sure you simplify this because most ratios are going to need to be simplified on your EOG or your benchmark. But just make sure if it says to simplify that you simplify. And in this case, 6/12 can be reduced, and we can use a proportion to figure that out. So 6/12 is equal to what over what if we reduce it? Well, we have to find the greatest common factor for 6 and 12, of course. And I know that 6 can make itself, and 6 can make 12. So I'm going to divide both of these by 6. 6 divided by 6 is 1. 12 divided by 6 is 2. So basically 6/12 is equal to 1/2 is my proportion that I can write. And to put that into the form of a word problem, and there is a correction needed to be made on your ratio table sheet that's in your packet, and so I use this problem because this is the corrected problem. My lemonade has a ratio of 2 lemons to 5 cups of water. How many lemons would be needed for 20 cups of water? And a proportion is going to come in handy here. So for every 2 lemons, I have 5 cups of water. And I can make that in a table just like on your paper. So if I make a table, my table would look something like this. This would be lemons. And I need 2 lemons. And this would be water. And I need 5 cups of water. Well, it says how many lemons would be needed for 20 cups of water. So I can just fill in here with the 20 here. And I don't know the number of lemons that I need, so I'm going to put a question mark there. So I can go ahead and write this as lemons over water or water over lemons to figure out what the missing number is here. It doesn't matter, okay? So I'm going to put 2 over 5, 2 lemons for 5 cups of water is equal to, well, since water is on the bottom here, water has to be on the bottom on this side in this fraction. So I'm going to put my 20 because it represents the amount of water that I want. And so it's going to go on the bottoms because in a proportion, what's on top has to be on top in both fractions, or what unit you're talking about has to be on top in both fractions. And the same thing with the bottom. The units on the for the denominators have to be the same. So I couldn't put money here and pounds here. It has to be money, money, pounds, pounds. So I have my lemons on top and my cups of water on bottom. So then I just figure out, how did 5 become a 20? Well, 5 became a 20 by multiplying it by 4. And then I use the rule, whatever you do to the denominator, you have to do to your numerator. So I'm going to do 2 times 4, and that's going to give me 8. So I would need 8 lemons to make, for every 20, if I have 20 cups of water, I would need 8 lemons to make my lemonade.